Okay, this is a really quick proof which we can do by mathematical induction, so long as you understand how inequalities work when you're trying to manipulate them, okay? So this is what I've been asked to prove, that n squared is greater than or equal to n, for n being positive integers, okay? So 1, 2, 3, 4, 5, 6, 7, and so on, okay? So a proof by induction, it always starts by testing the first allowable value, okay? So I'm going to test n equals 1. So on the left-hand side, I've got 1 squared, which is 1. On the right-hand side, I've got 1. And sure enough, the left-hand side is greater than or equal to the right-hand side. Okay, and therefore it's true for that first value. Okay, next, we want to assume that the statement is true for some value. Okay, so it's true for n equals, and let's make it k, where k follows the same rules that n follows, namely it's a positive integer. Okay, so what does that look like? Well, it looks like this, that k squared is greater than k. I've just substituted. Okay, now on the basis of that assumption, what I want to do is prove that it's true for the next allowable value. Okay, namely k plus 1. What happens when you substitute all that in? This is what you're going to have. Okay, so this here, this is what I'm required to prove. Okay, how do I do it? What I'm going to do is start with my assumption here, and then I'm going to try and do what I need to twist and turn it so I can arrive at what I'm trying to prove. Okay, so I'm going to say by assumption, okay, k squared is greater than or equal to k. Okay, so far so good. Well, let's do some valid things to this. I can just add 1 to both sides. Now the reason why that's useful is because now I have the right hand side looking exactly how I want it, so I don't need to muck around with that anymore. Now, what can I do here? Well, if I've got k squared plus 1, right, since k is positive, I can say, well, k squared plus 2k plus 1, right? If k is positive, this thing must be bigger than that, right? It's got to be bigger than that, because it's the same thing, but I've added something onto it, okay? But I know that is greater than or equal to k plus 1, okay? So therefore, you know, I can actually eliminate this guy in the middle here. If this is bigger than this is bigger than that, and surely this must be much bigger than this, right? So I can say, therefore, k squared plus 2k plus 1 is greater than or equal to k plus 1. Now that's the crucial step, okay? It seems a bit funny, you know, you add this out of nowhere. Why do I add it out of nowhere? What it lets me do is it lets me factorize, because k squared plus 2k plus 1 is k plus 1 all squared, right? Which is greater than or equal to k plus 1. And that's what I'm trying to prove, namely that it's true for n equals k plus 1. Okay, so I can say, since the statement is true for the first allowable value, namely n equals 1, it must also be true for all the rest of them, n equals 2, 3, 4, and so on, namely all of the values where n is a positive integer. And that's the proof.